Good morning. The Subcommittee on Space and Aeronautics will now come to order. Without objection, the chair is authorized to declare recesses of the subcommittee at any time. And welcome to today's hearing entitled Advancing Scientific Discovery, Assessing the Status of NASA's Science Mission Directorate. I'd like to recognize myself for 5 minutes for an opening statement. Today's subcommittee hearing will review the activities of NASA's Science Mission Directorate, or SMD, and discuss the challenges and opportunities for ensuring success in these activities. Scientific research has been a core function of NASA since the agency's creation. NASA's science missions have helped us to learn more about our planet, discover secrets of the sun, explore our solar system, and better understand our place in the universe. SMD has had many recent successes. The Perseverance and Curiosity rovers are adding to our understanding of Mars and enabling us to someday send humans to the Martian surface. The Parker Solar Probe continues to deliver unprecedented observations of the sun. Just 6 months ago, OSIRIS-REx returned asteroid samples to Earth to be studied at the Johnson Space Center. SMD also carries out some of NASA's most important work by cataloging and defending our planet from near-Earth objects. However, we cannot celebrate these successes without acknowledging the challenges that NASA has faced on missions of all sizes. Just 3 weeks ago, NASA's Office of Inspector General released an audit of the Mars Sample Return Mission, commonly known as MSR, that NASA hopes to launch in partnership with the European Space Agency before the end of this decade. Anyone who has read prior reports on NASA's science missions from the Inspector General, GAO, or other independent review bodies will see familiar themes in this audit. Project management challenges, including over-optimism on technology development, evolving architectural requirements, and underestimating costs are but just a few of the challenges identified by the Inspector General. This committee recognizes the immense value of the MSR mission. We continue to hope that these issues will be resolved and that the MSR mission will be successful. However, we cannot ignore this now familiar pattern of schedule and cost overruns for many NASA programs. When missions are delayed, costs increase as a result. Ripple effects are felt throughout NASA as timelines shift and unrelated programs are delayed or canceled to accommodate the troubled project. Members of this committee undoubtedly recall the years of delays and billions of dollars in cost overruns before the James Webb Space Telescope was launched. Another mission, the Psyche spacecraft, finally launched in 2023 after more than a year delay, which incurred significant costs, impacted other missions, such as the Veritas mission, and we want NASA to engage in bold, daring missions. But Congress must direct NASA to take on these missions with a clear understanding of the associated costs and risks. Consistent cost overruns and delays can result in other worthy missions being postponed or canceled and can create a reluctance for Congress to provide additional funding or even approve such missions in the future. Congress has a responsibility to weigh the cost of a mission with its scientific value and cannot simply rationalize cost overruns and schedule delays by stating the end result of these missions will be worthwhile. That is unacceptable to our constituents and should be unacceptable to us all. This committee has long supported a balanced approach to NASA's scientific missions across discipline and mission type. I expect that will continue in the future. At Congress's direction, NASA relies on the decadal process carried out by the National Academy of Science to prioritize its scientific activities. This process seeks a broad range of community input to reach a consensus position on priority missions for the following decade. Recent decadal surveys across disciplines have recommended ambitious missions and optimistic budgets. This committee recognizes the importance of the decadal process, but must also recognize the current fiscal environment and plan accordingly. The focus of today's hearing is not to chide NASA, folks, but rather to understand the challenges that NASA faces when fulfilling decadal priorities. We also want to be sure that both Congress and NASA are applying lessons learned from previous missions to facilitate future mission successes. I thank our distinguished panel of guests this morning and witnesses for joining with us today, and I look forward to a productive discussion. And I would like to now recognize the ranking member for his statement for 5 minutes.
Thank you, Chairman, and I join the Chairman in welcoming everyone to today's hearing. We also thank our exceptional panel today of witnesses for being here to share your expertise. Thanks to the Science Mission Directorate, NASA is conducting reconnaissance of every planet in our solar system, studying the sun and near-Earth environment, better understanding Earth systems, and probing the evolution of stars, galaxies, and the early universe. As a scientist myself, the only meteorologist in Congress, I'm eager to highlight the importance of NASA's work to our nation and to my constituents back home in Western and Northwestern Illinois. Take, for example, the study of Earth science, a field which NASA's first of its kind Earth observation investigations are helping improve something near and dear to my heart, our nation's operational weather services. These services inform the study of trends of severe weather and tornadoes, flooding, droughts, which lead to how we use our land. This data can then be used by farmers across the Midwest and around the country. As an example, NASA's heliophysics programs to study the sun, which help us predict solar storms that can disrupt vital satellite communications and GPS signals. Speaking of NASA's scientific study of the sun, communities around the country will soon have an opportunity to learn firsthand about our closest star. On April 8th, a total solar eclipse where the moon passes between the sun and the earth, turning day into night for a few short minutes, will be visible in several states, including the southern portion of Illinois. Most of the country, including communities in central and northwestern Illinois, will witness a partial eclipse. And so I will remind everyone, the scientists in Congress, that we advocate you only use one of these when you're taking part in the solar eclipse. But also, I'd be remiss to say it was one of the greatest parts of my life driving from Illinois to Wyoming to see the last eclipse and the profound impact that it had on me personally. The opportunities for pursuing important science are vast. However, our fiscal resources are not. The Science Mission Directorate has many projects ongoing, but we do not have unlimited funds. That poses a problem because we need to balance between and among the projects under the Science Mission Directorate to maintain a healthy distribution of funds to small, medium, and large missions. Large, high-priority missions with significant resource demands have the potential to upset the balance within and across NASA's science programs. Today's hearing provides an important opportunity to examine the nature of this balance and how we can pursue ambitious and large missions while maintaining the overall health of the Science Mission Directorate portfolio. I'm eager to find solutions because leaving high-priority science on the chopping block is not the future that I want to see for the next generation and for our country. I'm proud and excited about what the future holds for NASA's science programs. Answers to so many important, challenging, and inspiring questions await us. I look forward to working with the chairman, NASA, and the administration, as well as stakeholders to ensure a bright and bold future for the space and earth science programs undertaken by NASA. And I yield back, Mr. Chairman.
Thank you, Mr. Sorensen. Really appreciate it. And now I would like to introduce our distinguished panel of witnesses today. Our first witness today is Dr. Nikki Fox. Dr. Fox serves as the associate administrator for NASA's Science Mission Directorate, where she oversees the Directorate's portfolio of over 100 individual missions. Previously, she served as the director of the Science Directorate's Heliophysics Division. Prior to joining NASA, Dr. Fox worked as the chief scientist for heliophysics at Johns Hopkins University's Applied Physics Laboratory. During her time at the Applied Physics Lab, Dr. Fox also served as the project scientist for NASA's Parker Solar Probe. We're looking forward to hearing from you this morning. Our next witness is Mr. George Scott, who I'd like to welcome back to the committee. He did a great job with Patton a few years ago, too. I just wanted to let you know. I guess that shows my age. Nobody's seen maybe George Patton. Mr. Scott serves as the acting Director General for NASA. He assumed the role in January of this year, having previously served as the Deputy Inspector General. Prior to joining NASA, Mr. Scott spent over 3 decades at GAO, which included serving as the Managing Director of GAO's Homeland Security and Justice team. Thank you for being here, sir. Our third witness is Dr. Jonathan Lenine, who serves as the David C. Duncan Professor in the Physical Sciences and Chair of the Department of Astronomy at Cornell University. He is also a member of the National Academy of Sciences and has chaired or co-chaired numerous advisory and strategic planning committees at the Academy and also at NASA. This includes chairing the Giant Planet Systems Panel for the 2023 Planetary Science and Astrobiology Decadal Survey. Dr. Lenine is also a co-investigator on NASA's Juno mission and previously served on the Science Working Group of the James Webb Space Telescope. And our final witness today, no stranger in here, is Mr. Thomas Young, the former director of NASA's Goddard Space Flight Center. He is also the former COO of Martin Marietta and chairman of SAIC. Mr. Young began his career at NASA's Langley Research Center. Throughout his 20-plus years of service to NASA, Mr. Young has held various roles, including the Deputy Director for NASA Ames Research Center prior to his time at Goddard. He is a member of the National Academy of Engineering and a former member of the NASA Advisory Council. So I would like to now recognize Dr. Fox for 5 minutes for your opening statement, your testimony. Thank you.
Thank you so much. Chairman Babin, Ranking Member Sorensen, and distinguished members of the subcommittee, thank you so much for the opportunity to appear here today. It is always great to have a chance to talk about NASA's science program. NASA's efforts to address fundamental questions about the universe and humanity's place continue to advance the United States' role as a global science leader. As you know, NASA released our FY 2025 budget request, which includes $7.565 billion for the Science Mission Directorate. This request supports over 125 space science missions, including 54 that are preparing to launch in the next few years, and over 70 that are in operation. The request funds U.S. scientists in universities, industry, and government labs through more than 4,000 openly competed research awards. The missions and the science undertaken by NASA are informed by the priorities laid out by the national academies, but funded by you, of course, the Congress, on behalf of the American people. We're grateful for the Congress's continued support of space science, which has produced some stirring successes, and I'm just going to highlight a few because I only have 5 minutes. As we enter its second year of operation, the James Webb Telescope continues to provide breathtaking results, with each captivating new image leading us closer to unlocking the great secrets of our cosmos. The OSIRIS-REx, as you noted, delivered samples from the asteroid Bennu to the Johnson Space Center, and these pristine samples, more than twice the requirement that was returned, are effectively time capsules from the earliest days of our solar system, from like 4.5 billion years ago. NASA is also adding 2 missions to its Earth science fleet this year. First, the PACE mission to study our atmosphere and oceans and the ecosystem was successfully launched from Kennedy Space Center in February of this year. And then the second one is NISAR, that is our first joint mission for Earth science with the Indian Space Research Organization. That's going to scan the Earth in kind of minute detail down to about a centimeter resolution with a first-of-a-kind dual-band radar. Our investments in commercial lunar payload services, or CLPS, are beginning to bear fruit. The first company in the world to make a successful soft landing on the moon was American. We're very proud of them. And it carried NASA and commercial payloads to the moon's South Pole region. This has also been a big year for the Heliophysics division. We noted 2 major solar eclipses. The first one very unusual, an annular solar eclipse that occurred in October when you would have needed those glasses for the whole thing. In coming up from Texas all the way up to Maine, as you noted, on April 8th. We hope you find a way to join us. Now we've given you glasses, so you're all set to go. Eyes will be well protected. And if you cannot get yourself to totality, fear not, NASA Science will bring totality to you. Our Biological and Physical Sciences division just presented their initial decadal response to the Academy as we drive forward with more and more discoveries about living and thriving in deep space. Later this year, as you noted, Parker Solar Probe, the coolest, hottest mission under the sun, will make its closest approach to the sun. It'll do its 7th Venus flyby, and it will go closer to the sun than any spacecraft has ever come to a star. We're also approaching solar maximum, which offers science opportunities related to these space weather hazards. We look forward very much to the launch of Europa Clipper later this year in October. Clipper will search one of Jupiter's moons, the Europa moon, for what we believe is a vast ocean that may hold evidence of life. We continue our work to protect the planet from asteroids with our NEO Surveyor, which is expected to launch in 2028. And both Clipper and Surveyor are joint NASA Center and JPL efforts. Work continues on the Roman Space Telescope, which is a NASA observatory designed to settle essential questions in the areas of dark energy, exoplanets, and infrared astrophysics. And we look forward to maturing the technologies that will be necessary to someday see planets that may harbor life. There are also challenges to overcome, as you've highlighted. Our mission to return samples from the surface of Mars has proven to be more costly than initially expected. In September, an independent review of the Mars Sample Return Program provided sobering analysis of the costs and challenges associated with this mission. This spring, NASA will complete an internal assessment of the mission architecture options and will inform the path forward and allow us to provide final details for the planetary science budget. NASA takes very seriously our responsibility to manage a very diverse portfolio within cost and schedule commitments. We continue to learn from our experiences, and we have instituted new policies to ensure we're constantly improving our ability to manage cost and schedule. It's our willingness to acknowledge these challenges and overcome them to conduct science in ways that have barely been imagined that makes us NASA. So thank you once again for inviting me to appear before you today, and I am really looking forward to answering your questions.
Yes, ma'am. Thank you very much, Dr. Fox. And now I'd like to recognize Mr. Scott for 5 minutes for his testimony.
Chairman Babin, Ranking Member Sorensen, and members of the subcommittee. Thank you for inviting me here today to discuss NASA's Science Mission Directorate. My testimony focuses on key challenges the agency faces in managing its science portfolio, including developing accurate and timely estimates, funding instability, and workforce capacity issues. Throughout its history, NASA has been at the forefront of incredible scientific discovery. And the agency continues to do the unexpected. For example, the Mars Ingenuity helicopter, the first aircraft to fly under its own power on another planet, surpassed 2 years of operations and completed 72 flights. Despite its long history of success, some of NASA's most impressive scientific missions, the Hubble telescope, the Curiosity rover, and the James Webb telescope, all experienced significant cost increases and schedule delays. The extra funding and time needed not only impacted these missions, but also created cascading effects across the agency's science portfolio. As we have frequently reported, NASA struggles to establish complete, credible, and transparent estimates. This is particularly true when it comes to large, complex missions. NASA's history of setting unrealistic costs and schedule baselines is due in part to the agency's culture of optimism. As we said over a decade ago, a culture of optimism and can-do spirit are essential for realizing groundbreaking scientific achievements and overcoming extraordinary technical challenges. That said, the same optimism may prevent leaders from critically assessing costs, risk, and schedules to determine what can realistically be accomplished within a set budget and time frame. To its credit, NASA has taken some actions to address its cost and schedule challenges. For example, in 2020, SMD completed its large mission study that examined how the agency makes critical decisions that impact mission and program success. However, NASA has yet to incorporate the recommendations from the study into its practices and guidance for flagship missions. Also, in 2020, the agency established the Chief Program Management Officer position to strengthen oversight and implementation of program management policies and best practices. Funding instability remains a concern. Unstable funding, whether in terms of the total amount of funds allocated to a project or the timing of when those funds become available, can contribute to poor outcomes. For example, inadequate funding early in a project can decrease management's ability to identify and address key risks early on. In other cases, moving tasks to later in the project may require managers to keep a larger workforce than originally planned, also resulting in increased costs. There's also the instability resulting from appropriations that lock the agency's funding at the previous year's level for extended periods. These uncertainties further compound the difficulties in effectively managing projects. Workforce capacity remains an issue for NASA. We have identified attracting and retaining a highly skilled and diverse workforce as a top management challenge for the agency. As early as 2018, we highlighted workforce capacity issues at the Jet Propulsion Lab. We are similarly concerned that other centers face the same challenge. For example, the Goddard Space Flight Center faces a heavy workload with large projects that are competing for a limited number of technical workers, even as these missions plan to launch in the next 3 to 5 years. NASA has repeatedly demonstrated its ability to overcome significant hurdles to accomplish amazing things. However, these achievements have often taken longer and cost much more than planned. Many of the agency's science missions are ambitious endeavors, and they need to be grounded in more realistic assumptions and estimates. Without this, it will be difficult for Congress to make informed decisions about NASA's long-term funding needs. Likewise, the agency will lack information needed to make difficult decisions on how best to allocate limited funds and prioritize future missions. We will continue to support NASA in achieving its scientific goals, while ensuring transparency and accountability for these efforts. Thank you.
Thank you, Mr. Scott. And I'd now like to recognize Dr. Lenine for 5 minutes to present his testimony.
Thank you very much, Chairman Babin, Ranking Member Sorensen, and distinguished members of the subcommittee. Thank you for the opportunity to present my views on the status of NASA's Science Mission Directorate. It is difficult not to feel passionately patriotic and proud of what our nation has accomplished in space science. As a scientist and academic whose entire career has been spent working on NASA programs, I am grateful to have participated in the development and execution of some of the greatest space science odysseys ever undertaken. The Voyager flyby of distant Neptune, the Cassini exploration of Saturn, the ongoing Juno mission at Jupiter, the Europa Clipper mission set to launch this October, and the James Webb Space Telescope. The accomplishments of our nation's space science program over the past quarter century are too numerous to recount, but we've all tried to list a few of them at least, and I'll try my hand at this as well. The discovery of an ocean capable of sustaining life in 2 moons in the outer solar system at least, Europa at Jupiter and Enceladus at Saturn. The first exploration of the sun from inside its atmosphere, the probing of ever more ancient epochs of the universe with Hubble and Webb, and much, much more. And the investment in space science that the U.S. has made over the decades is paying off in unexpected ways. For example, the Webb telescope is teaming up with other space telescopes like the Chandra X-ray Observatory to give us unprecedented views of cosmic processes over a vast range of the electromagnetic spectrum, from X-rays to the infrared. I want to turn now to Mars, where the nation's prowess in space technology will be most on display in the coming decade. 2 incredibly capable rovers designed and built with American technology by NASA's Jet Propulsion Laboratory have been roaming the Martian surface over the past decade in search of the clues to how Mars went from being a very Earth-like world to one that today is inhospitable? This is a profound question because its answer may well tell us how fragile the habitability of our own planet might be. How did Mars dry up? Exactly when? Did life begin on Mars and then die off? As articulated by NASA advisory groups in 2 successive decadal surveys of the National Academy of Sciences, answering these questions will require bringing samples back to Earth. Both Planetary Science decadal surveys identified Mars sample return as their highest priority. Why so? As we learn more about Mars and ask more detailed questions, instruments of increasing sensitivity, resolution, and sophistication are required, eventually exceeding what can be plausibly carried in a spacecraft. In laboratories on Earth, powerful analytic techniques can detect faint clues to the earliest history of Mars and to the possible presence of traces of ancient life. It is not enough to have these sophisticated geochemical tools in the laboratory. The samples must come from a place on Mars that was once Earth-like. NASA's Perseverance rover is in such a place right now, Jezero Crater. At the crater's western end is a dried-up river channel and an enormous delta-shaped fan of sediments deposited at the time that that river ran. This one complex region holds the potential for answering a host of questions about the geologic and climate evolution of Mars, and Perseverance is collecting samples carefully selected to provide those answers. But to realize that potential requires getting those samples back to Earth. Mars Sample Return is the most ambitious robotic program ever attempted, bar none. Much of the technology is new and challenging. Having served as a member of the second MSR Independent Review Board, I am supremely confident that it can and will be done. It can be done because American engineering prowess is up to the task. It will be done because as a nation we surely will not simply walk away from a daring, highly visible, and scientifically important challenge. In closing, let me point out that more than a half-century after the first moon rocks were returned by the Apollo astronauts, science is still being done on them today by instruments far more capable than those available in 1969, when I was 10 years old. The samples returned from Mars in the coming decade will be analyzed not only by scientists alive today, but by scientists who are not yet born, using laboratory techniques that are not yet invented. These precious records of early Mars will be a lasting scientific treasure and the legacy of American technological prowess. Thank you very much for having me here today.
Thank you very much for your testimony. I would now like to recognize Mr. Young for 5 minutes. Thank you.
Chairman Babin, Ranking Member Sorensen, committee members, I'm pleased to have the opportunity to present my views on NASA's Science Mission Directorate. Great organizations achieve great accomplishments. NASA's Science Mission Directorate has a legacy of great accomplishments. My examples of great accomplishments by SMD are Viking, Hubble, James Webb Space Telescope, and hopefully Mars Sample Return. Others might select a different set with equal merit. It would also be a mistake not to recognize the incredible contribution of projects from the Sounding Rocket and Balloon program to projects such as Parker's Solar Probe and weather satellites. What are the characteristics of projects that result in great accomplishments? Today, projects such as JWST and MSR originated from decadal surveys. The National Academy's decadal surveys are comprehensive surveys of a scientific discipline such as astronomy and astrophysics to identify the #1 priority project for development by NASA. The surveys provide a mechanism for the scientific community to speak with one voice in identifying the best of the best. Projects that result in great accomplishments travel extremely difficult development paths. Projects in this category push the boundaries of what is possible. This aggressive approach is necessary to obtain extraordinary scientific results, such as JWST results that are being experienced today. The difficult development path these projects follow are populated with incredible engineering, cost, and management challenges. Most, if not all, are threatened by cancellation. So what are the keys to the success of these projects that must test the limits of what is possible? Clearly, the exceptional people that make up the project organizations in NASA, academia, and industry are key. Superior leaders are required to provide bold and visionary leadership. Leadership that recognizes corrective action and not cancellation is necessary to achieve great accomplishments. These scientists, engineers, and leaders do not simply walk in off the street. They're a result of rigorous hands-on development and being trusted with significant early career responsibilities. NASA has a history of exceptional employee development. This development effort will be even more important as SMD pursues more challenging projects in the future. Next, I would like to discuss MSR. Today, MSR is in the balance as to whether it will be allowed to follow the path necessary to become an SMD great accomplishment, or will it become a monument to a missed opportunity? I do not want to minimize the technical cost and management problems identified by the Independent Review Board. The problems are significant, as are NASA's and our country's budget challenges. MSR is identified as the #1 priority in the past 2 planetary decadal surveys. The expectation is clear that when the samples are analyzed in the highly capable Earth-based laboratories, MSR will join the SMD legacy great accomplishments. Today, the future of MSR is in the hands of NASA, congressional, and administration leaders. Bold, visionary leadership is needed to put MSR on a path to success. The future of SMD is populated with incredible opportunities. Many are focused upon civilization's great question, are we alone? We must continue to improve our project management capabilities to realize the potential that the future holds. My thoughts on some of the required improvements are cost estimating, better cost estimating of most probable cost and not relying upon lowest credible cost or for early decision making is required. Systems engineering. Improved systems engineering is needed to develop architecture and interfaces that are the simplest possible to achieve project objectives. Employee development. Developing scientists, engineers, and leaders will continue to grow in importance. Contracts with industries that focus upon buying services as opposed to hardware, systems integration, operations, etc., minimize development opportunities. SMD strategy. A balanced SMD strategy is a worthy objective. However, implementing projects such as Viking, Hubble, JWST, and MSR will likely not be possible without accepting some impact on other activities. This should be acceptable to accomplish great accomplishments. Project management. Future projects will require the full capabilities of NASA. This includes NASA's senior management, the Science Mission Directorate, and the NASA centers, including center directors, project managers, and their respective organizations. The hallmark of a great organization is the willingness to accept difficult challenges to achieve great accomplishments. I believe SMD is such an organization, and that the future of SMD will be bold, exciting, scientifically rewarding, and a source of great national pride. Thank you very much.
Thank you. I appreciate all of you witnesses for your testimony. And now I would like to recognize myself for questions for 5 minutes. Dr. Fox, NASA stood up an internal group to develop a response to the second independent review team's assessment of the Mars sample return program. When will NASA be prepared to share the results of this internal review with Congress. We want it to be successful.
Thank you so much for the question. We are wrapping up putting together the results. They will be available in the spring. But literally as soon as we can get them to you, we will.
Good. Today, I think, is the first day of spring. You don't have it ready yet, huh?
Spring's a lovely term.
Right. All right, well, thank you. Congress, also for you, Dr. Fox, Congress directed NASA to discover and characterize at least 90% of the near-Earth objects, or NEOs, that could cause significant damage if they collide with Earth. NASA is years behind the deadline that Congress set to complete this survey, which is one of the few tasks that NASA is directed by law to complete. The NEO Surveyor mission is an important part of completing this survey. And what is the status of the NEO Surveyor mission?
Happy to say that NEO Surveyor is on track. It will launch in 2028, and we really do appreciate the support that we've had to keep that mission funded through even this challenging year. So NEO Surveyor is looking good.
Good deal. Thank you. Mr. Young, in September 2020, NASA's Office of Inspector General, the OIG, released a report on NASA's planetary science portfolio. The report highlighted NASA's challenges in adhering to Discovery-class mission cost caps. In particular, the report stated that even when excluding launch vehicle and operations costs, none of the Discovery missions are under the $500 million cost cap. What are the consequences of breaching a cost cap? Does a tolerance for cost cap breaches have an impact on program discipline for future Discovery-class missions? And how are other non-Discovery-class missions in the pipeline going to be impacted when these cost caps are breached?
Summarized it pretty well. That will happen. It's important to look back as to why the cost breaches. And one of the items is that we continually, for good scientific reasons, select more and more challenging opportunities. And as we do push technological limits, we are in a circumstance where a priori understanding of the precision of the cost is just not there. So I think that, if we wanted to have less testing of the cost or the schedule limits, it really says select projects that are less challenging. The problem with that is they're also less rewarding, and so it's a difficult circumstance, and it's one that Nikki and her organization have to really balance. But what you describe is true. If they're all increasing in cost, they're going to push something else out that's not going to be able to fit into the project, into the budget. But on the other hand, testing where you get the best return for the amount of money that's expended is something that deserves an awful lot of scientific analysis and systems engineering analysis before projects are implemented.
Thank you. Mr. Scott, in February 2024, NASA's Office of Inspector General issued a report on the Mars Sample Return, or the MSR program, as we've heard several times today. The report noted that characteristics intrinsic to big and complex missions like the MSR program are hard to quantify in estimates but can drive project costs upwards throughout development. The report stressed that NASA must consider these intrinsic characteristics and cannot attribute past cost growth to inflation, the COVID-19 pandemic, or to supply chain issues. Can you describe these intrinsic characteristics of large missions and their effects on the cost program?
Thank you, Mr. Chairman.
On the program cost, rather.
Thank you, Mr. Chairman. Yes, as we've discussed already in the statement, says just a number of factors continue to drive the cost increases in large programs like the Mars Sample Return, whether it's the initial baseline estimates either provided by the decadal, which are early on and often lack the complete picture of what some of these missions will cost. There's also workforce issues that can end up driving the cost, increased costs for these missions. The lack of maturity of some of the technology is also a key driver in some of these large complex missions. That's why we think it's important for NASA to start to implement some of the recommendations from the large mission study to better inform going forward where you put the attention early on in these large projects.
Okay, thank you, and it looks like I'm out of time, so I'd like to recognize the ranking member, Mr. Sorensen.
Thank you, Mr. Chairman. I'll begin with Dr. Lunine. Last year, I was able to welcome NASA astronaut Dr. Kate Rubins to my district. And over the course of 2 days' time, we visited numerous schools. And it was really great to hear her explain the importance of what we are learning from the Apollo mission and what we were able to bring back from the lunar surface. Could you please expand on what scientists will be able to learn with the samples that we hope to get back from the Mars surface?
Sure. Thank you very much for the question. To answer that question, I will go into my hour-long lecture, but since I don't have that time,
4 minutes and 10 seconds.
yeah, I'll give you 4 points. So first of all, we do not have a chronology of the early history of Mars that's on an absolute timetable. That is, we know the relative times that events happen, but not the absolute times. And for the Earth and the Moon, the Apollo samples gave us that for the Earth-Moon system. That was one of the most profound scientific accomplishments of Apollo, to know the dates that things happened. And so we'll learn that for Mars from those samples from what's called radiometric dating. And that can be done, really needs to be done in terrestrial laboratories because you have to be able to look at what are called multiple isotopic systems to do that. So leave it at that. Second, we will learn about the question of whether organic molecules were present with the water and what the nature of those organic molecules were. You can detect some organic molecules on Mars itself, but it's a very faint signature, and to be able to detect molecules that are not well preserved requires instruments that can detect abundances that are well below what you can bring to Mars. Number 3, of course, the question of life and whether there is fossil evidence of life. The experience of geologists on the Earth with very ancient life is that it requires laboratory instruments to find the chemical and physical clues, because those clues over billions of years have become very, very faint, and the same for Mars. And the third is that because the crater that Perseverance is in is formed by an impact, it excavates material from deeper under the crust. And so to be able to sample that material and bring it back to Earth and determine the mineralogy of that material is an outstanding opportunity to know what's underneath the dusty surface of Mars. And I'll leave it at that.
Yeah, thank you for sharing it. We could probably talk for a long time
I could,
on
yeah,
this
that's
subject.
true, yes.
I do want to go to Dr. Fox. Let's bring this back to our planet. The Landsat satellite system has provided continuous land imagery of our globe for 50 years. Not just as a meteorologist have I used this data, but the University of Illinois has utilized this in agriculture. And then also I'd be remiss if most of us on Capitol Hill aren't a little bit raspy today because of the fires out in Western Virginia or the fires in the western part of the chairman's state of Texas. How will NASA's development of the next generation of Landsat satellites, Landsat Next, be important for districts like ours?
That's a wonderful question. I, like Jonathan, could give you an hour lecture. But I mean, Landsat is a critical part of our complete Earth monitoring system. And as you note, wildfires do not follow boundaries. They don't follow state boundaries. We all breathe the same air, as we found last year from the Canadian wildfires. So a lot of our new missions, Landsat clearly, set to take that next step for Landsat Next. It's really a different generation of Landsat. It also, I would be remiss if I didn't mention our surface biology and geology mission that will also just give us this unprecedented views of what we are doing. We just launched PACE, and that is not only telling us about ocean health, but also about the health of the air that we breathe. So Landsat clearly a very key part, but it really is in this sort of strength of bringing all of these diverse measurements together to really allow us to do a great job of characterizing our planet.
I want to be cognizant of time, so really quickly, Mr. Young, you stated that there are difficult development paths, that projects that result in great accomplishments travel extremely difficult development paths. What do you think we in Congress need to do to consider when we are looking at these projects ahead?
A quick summary, I would say that we need to look at the difficulties that have occurred and apply lessons learned to the next series that exist. And that is, I think we know that we've got issues in cost estimating, we've got issues in systems engineering, we've got issues in developing the required talent to implement these programs, and we need to very clearly specify them and have a coordinated effort to improve significantly in order to be able to do the challenging things that are in front of us in SMD.
Thank you. Learn from the past to make good decisions for the future.
Absolutely.
Thank you, Chairman.
Thank you. I'd like to recognize the gentleman from Florida, Mr. Posey.
Thank you very much, Chairman Babin, and I want to thank the witness for your illuminating testimony today. Very, very much appreciated. Mr. Scott, has the way NASA managed its high-end computer capabilities hampered at all in any way that you know its ability to properly monitor the foreign national accreditation access process?
Thank you, Mr. Posey. As we recently reported, we did raise issues about the 700+ foreign nationals that to date have been identified accessing the high-end computing capabilities. Again, the issues that came to light were one of the ability to better understand the number of high-end computing systems NASA has running. It's diffuse, spread out across the various centers, and being able to better understand and track and monitor who's actually on the system and ensuring that these diffuse systems have the adequate cybersecurity controls.
Thank you. Do you think the use of NASA's high-end computing by external and foreign national parties is as persuasive as the Inspector General's report might have indicated?
Again, we've asked NASA to set up a Tiger team to look and better understand the number of external users and foreign nationals accessing the system. Right, it's a both and. Right, it's important for scientific reasons that folks have access to the high-end computing, and it's equally important that we understand who these folks are, what they're accessing, and being able to track and monitor their use of the systems.
Thank you. Of the more than 700 foreign nationals the IG report says have accessed the system, are you aware of any from any country of concern, such as China or the cities of Macau or Hong Kong?
I'm not aware of any foreign nationals from any countries of concern. NASA does have a foreign national accreditation process. And so my understanding is the folks on the system have gone through that process. What we're asking NASA to do is better ensure that the folks responsible for the high-end computing capabilities are part of the accreditation process. And again, making sure these systems are up to date in terms of their cybersecurity controls, and we're able to monitor the activity of those on the system.
That's great. Has NASA expeditiously implemented the recommendations in the Inspector General's report?
We're awaiting their responses. We believe that their initial responses will address the recommendations we made, but again, we're waiting to see exactly when they're implemented the various recommendations.
Okay. Dr. Fox, is NASA working to fully implement the Inspector General's recommendations concerning high-end computer capabilities to restrict access by external and foreign national parties?
NASA really appreciates the receipt of the report from the Inspector General's office. Extremely helpful report. We are in the process of responding to each of the recommendations and putting together the team as requested to actually do this deep dive study.
Okay. Mr. Chairman, I ask unanimous consent to include in the record of March 2024 NASA's Office of Inspector General report.
Without objection, so ordered.
Thank you, Mr. Chairman. I yield back.
Yes, sir. Thank you. And now I'd like to recognize the gentlewoman from Virginia, Ms. McClellan.
Thank you, Mr. Chairman. As the only member of the committee from Virginia, I'm particularly proud of the work being done at Langley Research Center, which I've had the opportunity to visit, their work to advance science not only in the Commonwealth but around the country. And I have to say that as a mother to a son who wants to be an astronomer, he is a keen fan of the work that you all do in the planetary science and helioscience divisions. He has used images from the Hubble and James Webb Space Telescope for school presentations and as a junior volunteer at the Science Museum of Virginia. And those images have sparked an interest in STEM more than anything that his father and I have ever put in front of him. And I am very hopeful that he will one day be one of those scientists that Dr. Lunine talked about, who will be studying samples brought back from Mars. And thank you very much for the glasses, because he told me the other day that we needed special glasses. He's very much looking forward to the eclipse. So you have definitely gotten me some cool points today. We know that funding stability is essential to maintaining a highly skilled workforce, which enables our continued national leadership in research, innovation, and exploration. And Dr. Fox and Mr. Scott, could you tell us if the President's fiscal year 25 budget request sufficiently funds the Science Mission Directorate to prevent future workforce reductions or some of the challenges you've discussed today?
Thank you very much. I'll be happy to yield an extra pair of glasses for your son to
Thank
make
you.
sure that he's protected too. We're very grateful for the President's budget request, the FY25 President's budget request that does fund NASA at $7.565 billion for science. That is below the enacted 23, so it does provide challenges in the portfolio. The bulk of those challenges are in the planetary science division, as you noted, and we are working very closely with our centers, with our teams to try and limit the impact of those reductions.
And can you tell me what strategies NASA is implementing to prevent attrition and ensure the stability of your workforce?
Again, we're working extremely closely with the centers to understand any impacts of the various challenges. Obviously, with Mars sample return, with following the recommendations from the IRB, we have paused the development of some of the aspects of Mars sample return while we look at all of the architecture, the different architecture studies. And so, as I know everybody is aware, that did cause some workforce losses at the Jet Propulsion Lab, which of course our hearts go out to anyone who has to do that. But that was done as a result of budget limitations there. But we are working extremely closely with all of our centers and of course with JPL to try and minimize and more importantly to actually sustain the critical workforce that we need to be able to do these amazingly daring missions that we want to succeed with.
And could you discuss any potential impacts to the Science Mission Directorate projects at Langley specifically if NASA's top line fund either remains flat or these cuts take place?
I don't have a full, let me start again. So for Langley, the biggest impact will be in the Earth Science division because of some of the delays and the change in the way that we will be implementing some of the Earth Science missions. So there will be some impact to Langley there. They also do have critical work with us in Mars sample return, but they do also have work with Dragonfly, which is well funded, and so we're hoping to be able to balance between some of the missions that are more robustly supported and some that may be a little skinny down in the FY25.
Okay, and in my remaining time, you may not be able to answer this here, so I'll submit this for the record, but your bridge program that develops partnerships between your centers and institutions that are historically under-resourced, like minority serving institutions, community colleges, and tribal colleges. I wonder if you could, for the record, provide an update on the status of the bridge program and some of its outcomes.
We'd be very happy to provide that for the record. I know the time's done, but I will say we are really, really excited about our bridge program for all the reasons that it's always nice to be able to offer people opportunities, but to be able to actually support them, to be able to take advantage of those opportunities is what we're doing with our bridge program. So thank you for the question.
Thank you, Mr. Chairman. Now you're back.
Yes, ma'am. Thank you very much. I'd like to recognize the gentleman from California, Mr. Garcia.
Thank you, Mr. Chairman. Thank you all for being here, to all the witnesses, your contributions to the country and to science and to our nation's security. You won't find a bigger fan on the Hill of NASA and the private-public partnerships that we're enjoying. This is a true space renaissance. And I should say that with all deference, Mr. Chairman, you probably are just as big a fan of NASA and the private partnership as I. And so, you know, this is not coming from a place of being combative, but trying to be cooperative in the spirit of being successful for these missions, especially the science and national security implications that a lot of these missions carry with them. And while I appreciate the Eclipse sunglasses, I would have preferred a set of glasses that would have prevented me from being blindsided by the actions that the administration has taken over the last few months when it comes to the Mars sample recovery program. Mr. Young said that the fate of MSR is in the hands of NASA as well as Congress, and I disagree with that. It certainly doesn't feel that way. I think we have a better relationship than what I think you assumed, and you left us in the dark, frankly, with some reprogramming that took place under loopholes during the CR. As the authorizer on this committee and as the appropriator on CJS, I would have really appreciated a heads up that we were going to lay off close to 600 employees at JPL before that decision was made. I was aware before it was executed, but not before that decision was made. And we have caused irreparable damage in those decisions. And I understand that the Senate mark was at $300 million and ours was at $975, and we were in the midst of a CR, and there's a lot of uncertainty and ambiguity there. And as a former, program director myself of $100 million programs, I understand that uncertainty is not good. But we could have cooperated, we could have communicated, and we could have landed on a place where maybe we should have preserved those jobs. And what's happening now is those folks that were at JPL aren't just leaving JPL, they're leaving the industry. In many cases, they're leaving the state, and we're losing a cumulative of anywhere between 3,000 years and 5,000 years of corporate knowledge of engineering and design and early development design work, expertise that ain't coming back. And so I don't know how we're going to address the workforce issues. It was a premature decision. It was prior to the IRB response team recommendations that we're expecting here in the spring. And I understand you can drive a truck between the $300 million and the $975 million or so that the House marked to. And that's uncertainty, and I definitely have received your message that CRs are bad, but I think you exploited that. I think you exploited loopholes in the CR language to fund a level that is well below congressional intent and certainly well below executability levels. So I've submitted a letter to the administration, to Administrator Nelson, with 20 colleagues. By the way, I'm the only Republican on this letter, so this is a bipartisan thing from California requesting that you fund MSR at $650 for the remaining part of FY24. I understand that's going to require some reprogramming and different profiles on your cost expenditures. We'd like to see a response to that, but I think we are also asking to not have any other reductions in forces, RIFs, or layoffs as a result of the decisions already made, so that we can try to salvage what workforce talent we have there as well. So I guess, Dr. Fox, my question is, will you comply with the direction in the FY24 spending bill, which hopefully will be executed here shortly, to not further reduce staff on the Mars sample return program?
Thank you for the question, and actually really thank you for your unwavering support of the Mars sample return. I really genuinely mean that, and I really do appreciate your support on that. We did brief Congress a number of times, the appropriations on the plans for Mars sample return. I think I actually had the pleasure of speaking to you myself.
I appreciate that.
And with the uncertainty, if we had allowed the spending on Mars sample return to continue at, or to continue at the 2023 level, we would have breached the Anti-Deficiency Act before February. And of course, we did not want to in any way do that. So we took the measures to limit and to actually follow the recommendations of the Independent Review Board.
I'm running out of time, but I want to ask the question looking forward. Looking forward for the rest of the fiscal year, are you committed to not reducing additional staff? And will you commit to allocating sufficient funding in FY24 and 25 to ensure the timely retrieval of samples of Mars? And I want to be very clear. I support you. I support NASA in this program, but it's not unwavering. If we can continue to show premature and, in my opinion, reckless behavior patterns out of reprogramming, I will want to do deeper dives into the program and ask even more questions. But if you can answer the questions for the record, you commit to retaining the current staff levels as they are for the rest of the year moving forward, and in an FY25 continuing to follow our congressional intent with funding levels to execute the program sufficiently.
So we look forward to the results of the independent review team that will be coming out in the spring. And we certainly commit to work closely with JPL to continue to maintain the critical workforce that will be necessary to do these missions.
Okay, I thank you. I'm out of time. I yield back.
Thank you, Mr. Garcia. Good questions. I'd like to call on Mr. Strong, my friend from Alabama.
Thank you, Chairman Babin, Ranking Member Sorensen, and our witnesses for their testimony today. I understand 2 proposals from Marshall Space Flight Center were not selected in a recent Science Mission Directorate call. These proposals were for concepts called Moonbeam and LEAP. Moonbeam was the highest rated astrophysics proposal and the only proposal to receive a Category 1 rating, the highest rating possible. Dr. Fox, Mr. Scott, what is holding NASA back from making these competitive awards?
Thank you for the question. There are many factors that go into why things are selected and not selected. For this particular one, we did not have the resources available to be able to support a mission of opportunity.
Okay. The Mars Ascent vehicle also just successfully finished its performance development review and successfully completed wind tunnel testing at Marshall Space Flight Center. The Mars Ascent vehicle, a crucial element of Mars sample return program, is a top priority within the decadal, I think that's the program they call it, the survey. Dr. Fox, Mr. Scott, what is NASA doing to meet its commitment to the survey's priorities?
Yes, as you note, it was the highest priority not only of the current decadal but of the previous decadal to bring our samples back from Mars, as Jonathan also talked about. At the moment, we are reassessing because we had that independent review board that released their findings last October. We have an independent team at NASA that is going through each of those findings. And so while we're looking at the restructuring that was recommended by that independent review board, we do have some elements of Mars sample return paused because we are being good stewards of taxpayer money and we don't want to go forward and spend money that would then not be realized. So that is the plan. But stay tuned. In spring, we will roll out the results of the findings of that team and hopefully get Mars sample return back on a path to be able to bring those extremely precious samples back from the red planet.
We're anxiously awaiting. Marshall Space Flight Center also hosted the ISS Payload Mission Control Center, which manages many research payloads aboard the ISS. Dr. Fox, how does NASA plan to ensure that researchers can seamlessly transition their experiments from the ISS to the commercial LEO destinations as they become available?
That's a great question. I could talk for hours about the great stuff that we do on ISS, trust me. But we are investing. We're working with partner agencies, with NIH, with the FDA, with the Human Research Program, of course, and with BARDA, our Biological and Physical Sciences Division. I think they have about an $18 million investment right now in things like tissue chips, so growing organs and sending up, you could actually envisage sending up a mini you on a chip and then looking at how you do respond to different medications. And so planning to do this sort of rapid development and working hand in hand with our commercial partners to look at exactly what it would take to transition from this critical science that we do on the ISS and get it ready to enact on whichever of the commercial LEO destinations that we go with. Obviously, when they put these in space, they want to use them, and so biological and physical sciences is a great customer, and we are ready to do amazing things, whether it's growing plants, looking at yeast and seeds and how they adapt. Also, I'll just note, already taking advantage of Artemis with flying on Artemis 1, flying a biological physical payload there, and getting ready to roll out the science that we're going to do on Artemis 2 as well. So just excited about the whole thing.
Man, I tell you, I can tell the excitement in your voice, and I thank each of you for being here today and the role that you play. Mr. Chairman, I yield back.
Sir, thank you, Mr. Strong. And I'd like to call now on our full committee chair, Mr. Lucas.
Thank you, Mr. Chairman. And to Mr. Young, when I joined this committee more than 20 years ago, the James Webb Telescope was in the early stages of formulation. And over that period, this committee engaged in extensive oversight of the development of the program. You led the independent review board that assessed the status of the telescope and testified to this committee about the results. From your vantage point, is NASA integrating lessons learned from the development challenges of James Webb? And it was a challenge.
And there were challenges, that's no question. In fact, you brought back a lot of interesting memories.
Oh, absolutely.
I would say the answer is yes. NASA has put together, and somebody can remind me the name of it, but a group of people that really went about and talked to a lot of people. I was one that spent some time with the group and trying to put together lessons learned. And so, yeah, I think there is an effort, to do that. I think the other thing, though, if I could hitchhike on your question, that I need to really emphasize, and you would appreciate this, these missions, the flagship missions that we're talking about that are pushing the boundaries of capability, they are never going to be easy. And they're never going to be free of challenges and difficulties. And I think that we've, the results of James Webb, in my view, maybe doesn't justify all of the issues that you had an opportunity to have a front row seat to, but they really did show that the perseverance of trying to get all of the issues under control, particularly those that were technical issues, many of which we found in the RRB that I chaired, came together and really have a system that got that launched that had 300 and some single point failures, any one of which would have been mission catastrophic, and for all of them to have worked is a credit to NASA and to the engineering capability of the project. So I'm bouncing around your item. I'd say, yeah, we are learning from it, but I do want to point out that these missions are never going to be easy and free of some of the challenges that exist. We should just get as many of them out of the way as we can in the process.
And I will remember, Mr. Young, that point in one of the hearings, the discussion that the complexity of the instrument, the complications of the launch, and the fact that we would put it out where we could never go put a pair of sunglasses on it, perhaps the way we'd done Hubble, was very unnerving. Mr. Scott, your testimony highlights that an issue for many NASA missions is the culture of optimism that results in unrealistic cost and schedule assumptions. Our committee encourages NASA to pursue bold missions, but how can we encourage NASA to establish a more realistic cost and schedule projections for the agency's science missions?
Thank you, Chairman Lucas. A can-do spirit is helpful and necessary for the things NASA does. That's without question. What we're asking the agency to do, though, is continuing to make critical assessments, particularly of these large flagship missions in terms of cost, schedule, and requirements. And that means asking the hard questions about these missions, even if the answers aren't favorable to your project. It's important to balance the sense of optimism and can-do spirit with realism, particularly as it relates to the lack of maturity in some of these technologies, the scientific, balancing that with the scientific value of these missions, but really being able to more fully understand the challenges ahead and try to better balance these cost and schedule issues. The other issue is the decadal. I'm sort of somewhat sympathetic to NASA. The decadal survey puts out estimates of some of these projects, but those are early estimates. Those are immature estimates, and yet those become the yardstick by which eventually we start to judge NASA. So I think it's also making sure we better understand what those decadal estimates mean, and then holding the agency more accountable as it fully matures and develops these additional estimates.
Dr. Lanine and Mr. Young, this committee is working on a NASA authorization bill. And our bill sets NASA policy, but does not provide funding for the agency. Recognizing the fiscal environment in which we are operating, how do we set policy for NASA's Science Mission Directorate without creating unrealistic expectations for the agency, which will be difficult to fund? How do we temper our optimism so they can be practical?
Well, I'm a scientist and not a policy person, Mr. Chairman.
You're a lucky person.
Yes, thank you. I know that, recognize that every day. I would just say that, and this isn't really answering your question, but I feel that the nation's portfolio of space science projects represents something that, looking back to this time in the future, will be seen as one of the remarkable accomplishments of this nation in terms of what we've done in exploring the universe and exploring our own Earth, the planets, the sun, and being mindful of that. Those decisions are very difficult to make, and I recognize that, and I hope that those can be made with as much knowledge and perspective as possible.
If I could add to that, I think one of the things that has to be recognized with the task that you have is that that there's a collection of activities that NASA does in the science arena that are probably better understood than something like James Webb Space Telescope is. So I think it's important to have a foundation of programs that advance the scientific understanding, but that are not challenging the limits of possibility. But on the other hand, I think if we look back a decade or 2 decades from now, and we have not been bold in including within the baseline of programs I'm talking about, programs like James Webb, like Mars Sample Return, I think we will collectively be disappointed that we did not pursue the opportunities that were there. And I think, again, what I was saying is pursuing those opportunities is really what's going to make the road difficult. I recall going back to James Webb, if I could spend just a minute, and I spent a lot of time up here interacting with when it was kind of also in the balance. But fundamentally, the question I got asked regularly was James Webb a step too far? And after I thought about it, bear with me as I answer, I think the answer is yes. But if we had not taken a step too far, we would not have the incredible results that we have today. Now, you can't do that with everything, but there are special things like Hubble, like James Webb, and I happen to agree with Jonathan, and like Mars Sample Return, that taking a step a little bit too far is in the best interest of justifying the potential results we come back, because it's the flagship missions that are going to kind of provide the James Webb kind of results, and I don't want to minimize the other, but everything can't be done that way. But a program that's absence of those kinds of programs would not be a program that we would be proud of.
Well put, Mr. Young, and thank you, Mr. Chairman, for indulging me. Yield back.
Yes, sir. Good questions. Thank you, Mr. Chairman. I'd like to call on Mr. McCormick from Georgia. 5 minutes.
Thank you, Dr. Chair. Appreciate you and appreciate the witnesses being here. Exciting topic. I will say, as a naval aviator, ER doc, and soon to be payload specialist, I'm very interested in this topic. especially with NASA and its future activities. I'm worried about some of the things that we need to do to sustain a budget for NASA as we go forward and to be applicable but also accountable simultaneously. I would be remiss if I did not mention that the Science Mission Directorate seems to be plagued by the same issues as many of NASA's other departments, which constant deadline extensions, flawed cost estimating processes, and poor financial management at times. I hope that today's conversation can lead us to identify key issues and find ways to mitigate these resource constraints. I'm excited about NASA's successful test of the Double Asteroid Redirection Test, which is DART for most of us others. That program demonstrates the method for deconflicting an asteroid through kinetic impact and the implication it could have as a key to our goal for planetary defense, which I think is kind of cool. We've seen movies on this. I think Bruce Willis had a great depiction of, or maybe it was a documentary, I'm not sure, of how we mitigate that risk in the future, because it is a real concern. I mean, we don't know when it's going to be, but we might as well have that capability in the future. Dr. Fox, now that we have successfully demonstrated the DART program, what's the next for this program, and will we create multiple DARTs on standby for possible near-Earth objects?
What a fabulous question. The next thing in the planetary defense is the NEO Surveyor, which of course will be critical in characterizing and cataloging anything that could need us to have a sort of DART Part 2, if you like. We don't have plans at the moment to have sort of little darts in storage. We don't have the resources in the planetary defense. We are, however, sort of, I think, probably recycling maybe is the good way, sustaining, but we are reusing the OSIRIS-REx spacecraft. So after that gave us those precious samples from Bennu, it dropped the capsule and then did a nice maneuver, and eventually we'll actually rendezvous with Apophis, which is a small asteroid that will come fairly close to the planet, not too close, but fairly close. And so we're using that to go and study close up another asteroid. Of course, we have our Lucy mission doing flybys of all the Trojan asteroids. We have Psyche on the way to a heavy metal asteroid, giving us all different views. And I just want to paraphrase something that Deputy Malroy said the other day, which was, when she was studying in her planetary days, she was studying asteroids. We had no idea what they looked like, and now we've had these incredible close-up views. So we're doing such a great job, I think, of categorizing, understanding, and cataloging asteroids that could become problematic. So a very, very vibrant field for us, having survived asteroid autumn last year.
It sounds like you've done your homework, and it sounds like you have a lot of organizations. Sounds suspiciously like a heavy metal band. But with that said, how much do we spend in time coordinating with other nations in this efforts, in sharing information and our like-mindedness to survive something like that?
Yeah, I'm going to actually take that one for the record because I want to get you an accurate response with the actual organizations because I don't remember them now. But we work closely with worldwide. I mean, there are these sort of asteroid watch networks, and again, we will get you all that information.
Okay, yeah. More to the point, I think we're all watching space. The question is, how much are we coordinating our efforts to defend against something that could be catastrophic, and then how do we protect our own technologies while at the same time being able to share the information we need in order to protect ourselves. That's the next step, I think, in the evolution of what we're trying to achieve here with DART or whatever the next program is going to be. That's just something I wanted to point out.
Yeah.
Mr. Scott, I'm almost out of time. I got about 1 minute. What are the most concerning issues that you have written a report that has not been addressed by NASA?
Thank you for that question. I think it's not one issue. Annually, we issue a top management challenges for the agency, which really points to the long-standing challenges, whether it's getting humans back to the moon, addressing the cybersecurity issues. So while NASA's making progress addressing each of those key challenges, I would point you to our top management challenges report, which really summarizes at a high level, we believe, the top issues and challenges NASA is facing across its programs and missions.
Number one, what is it?
They're all my favorite. I think there's like 7 or 8 of them, so I don't have a number one.
You're treating them like kids, huh? You don't want to have a favorite. I get it. Okay. Well, I'd say in order for us to be accountable to people, just make sure that we're spending wisely. We budget process, and that budget process has to be streamlined a little bit better. Thank you, Mr. Chair.
Absolutely. Thank you. And I think everybody's asked questions, and so we're going to go back through with a second series, if that's okay with everyone. And I'm going to call on the ranking member, Mr. Sorensen, first.
Thank you, Mr. Chairman, and thank you again to our witnesses. As Congress is tasked here in the wee hours of the morning of a spending package that we'll be voting on hopefully very, very shortly, all eyes are on spending. And so I do want to go back to something that Mr. Young, that you said in your testimony. NASA should look at the most probable cost instead of the lowest credible cost. And so I do want to open this up to a more broader discussion because in 2020, NASA's preliminary estimate would cost $2 to $3 billion to bring the samples being collected by the Perseverance rover on Mars back to Earth. $2 to $3 billion was the estimate. Last summer, just 3 years later, the Independent Review Board said that a more realistic estimate is $8 to $11 billion, and that's still preliminary. How can we, as members of the Space Science and Technology Committee, or more broadly, members of Congress, continue to justify that this is worth it in the long run? I think as the chairman and I are scientists at heart, we understand the value of being bold, Mr. Young, as you had said. How do we continue to do that if the cost overruns keep going up?
I noticed there are no other volunteers. I'm trying to figure out how to do this within reasonable time. When projects are being put together and going through various approval processes within NASA, within the Congress, within the OMB, the thing that is, whether we like it or not, the thing that is encouraged is lowest credible cost. As Mr. Scott said, in that era, everybody is an optimist. And the difference between there's a lot of data that would support this, between a lowest credible cost on a statistical basis, I would say is like a 20-80. A most probable cost is like an 80-20. Those numbers are at least a factor of 2 difference. So what I'm really getting around to is that there's got to be some offsetting role, that everybody can't be in the camp of lowest credible cost, because we're going to end up with ridiculous numbers, as it's turned out, like $3 billion. Now, in a corporation where you're kind of betting the corporation, what do? Okay, if I go back to my previous life, what we did was we had project people who developed cost, and they were optimists, and we knew they were optimists, and we wanted them to be optimists to lead the kind of projects we were talking about, but we did not want to bet the company on their numbers. So we had independent cost estimating capability, people whose job it was to develop the most probable estimate. So my argument would be, in the front end of projects, we need to recognize that many of the numbers we're getting are lowest credible cost, and we need to have an independent capability to work on the objective of being, I'll call it junkyard dogs, people who are really looking at what this is really going to cost. And then the decision makers have got to recognize that these programs are difficult, and it's going to take most probable cost. So then we can make judgments against the more validity in the cost. So I believe we have capabilities to estimate cost. I think much of the sample return problem is not overruns in performance, it's overruns in estimating. and that we had, that's why I used the terms lowest credible versus most probable.
And I look back at what we were doing with respect to space and what it meant for us to get a computer in our hands that is this size and this weight. What is the value of the investment that we made back then? And we can't calculate what that is here today. And that's what I worry here in Congress as we're struggling to meet the needs of what it means to be bold in space. And so I hope that we are able to do the right thing and fund the right parts. Thank you, Mr. Chairman.
Yes, sir. Thank you. I just had a couple of follow-up questions. For Mr. Young, you chaired the Independent Review Board for NASA's Psyche mission. Similarly to the OIG's report, the Review Board report noted that delays attributed to COVID-19 may actually be rooted in deeper program issues. I'd like to provide you with an opportunity to discuss the characteristics of large missions that contribute to delays and cost increases, if you don't mind.
Psyche is an interesting example, and it was done during the COVID time period. So there's no question but what COVID had an adverse impact on Psyche and projects, because project management is a team sport. And what I mean by that, it is people really need to be face-to-face and to work it out. But it would be wrong to blame even a majority of Psyche's problems on COVID. It was certainly a factor. But Psyche clearly had started as some software development problems in the guidance and control of software that were poorly communicated throughout the organization, were not recognized until it was too late to have corrective action that would have allowed the project to go on schedule. The other thing I would say with that is, to JPL's credit, when we interacted with them from the IRB standpoint, we really pushed hard on this issue of hybrid work vis-a-vis in-person work. And they put together a concept that recognized employees, maybe cultural differences, but necessary to make the project work. I guess the other thing I would say was that the IRB really stayed with JPL hand in hand all the way through the process. And they developed a path forward that when we first reviewed it, we said, you need to go back and there's some other things you need to do. And they did. And so, I mean, JPL and NASA's response to that, they accepted every recommendation we had. They responded to them. And Nikki probably remembers, but she came out to get a preliminary assessment of what we were doing. And my comment was at that time, which was true, that we had high expectations for what they were going to do, and they exceeded them. And so I think that really is, in my view, that is a textbook way that when you have a problem like that, that you go about solving it. And what NASA and JPL did in responding to our recommendations was we applauded quite significantly. And it's always rewarding, back to James Webb, where I chaired the IRB there, and I don't want to make this sound like taking credit, but it's always pretty nice, and you can then sit back and watch, like Psyche, it then launched on the revised schedule, and it's on the way to the asteroid Psyche, and is performing extraordinarily well.
Okay, thank you. And then also to follow up, the Space Mission Directorate periodically conducts reviews of its operating missions known as senior reviews. The reviews provide a valuable opportunity for NASA to leverage its investments by extending the operations of spacecraft that continue to provide useful data beyond their planned lifetime. And while a useful tool, I'm interested in ensuring that NASA allocates its funding in the most efficient manner possible. In particular, recent senior reviews across SMD's divisions have recommended extending the majority of programs being considered. Does the senior review process assess how continued operations of a mission would impact NASA's budget? And how does NASA weigh whether extension of an existing mission is worth potentially diverting funds from a future mission? Mr. Young.
Yeah, I'm not the person really to
Okay.
comment on the.
Then I bet it's
process.
Dr.
Yeah.
Fox.
Yeah, happy to
Okay.
talk about that. So, I mean, we really value the senior review process because if we do have to make tough decisions, it does give us that ranking. Of course, nobody ever wants their mission turned off, and why would you? I wouldn't want mine turned off. But it is challenging because when we talk about the balanced portfolio across the Science Mission Directorate, we really do mean in terms of our legacy missions with the new exciting missions. I do want to sort of highlight how the Earth Science Division has recently used their senior review. They got a recommendation to maintain all of their operating missions. They did not have the resources to do it. So what they actually did was give a very challenging budget scenario to each of those operating missions, and boy, did they deliver. So they are cutting those. The actual budget to finding creative, efficient ways to keep operating the missions. Maybe you can't do it in the way you've always done it before in prime mission, but there are efficiencies you can make to extend the missions, and we've seen that across the portfolio, where so we find that the senior review process very, very valuable. We do like it when they give us the ranking of the missions because it does make it easier when we have to make those hard decisions.
Okay, thank you very much, and I'm out of time. I'd like to call on a gentleman from California once again.
Thank you, Mr. Chairman. I want to follow up on the Mars sample recovery discussion that we had. I'm a dog with a bone on this one because it's so important to us, and the damage here is tremendous. Not to just my district, but to all of Southern California, to all of, frankly, the NASA workforce industrial base, and the implications of this bad behavior are far-reaching. This was premature, pre-decisional, based on pre-decisional conversations in Congress that were happening real-time between both the House and the Senate. Very short-sighted, and has caused irreparable damage. I describe this as nothing short of a bag job against the good folks at JPL, people who are now unemployed, looking for other industries, looking for other jobs, almost 600 folks as a result of this bad decision. It's a slap in the face to Congress, both the authorizers and the appropriators. So you mentioned, Dr. Fox, the Anti-Deficiency Act. The Anti-Deficiency Act is meant to be a way to ensure that agencies aren't spending more than what they are appropriated to. Your FY23 appropriations number was $818 million, 818.8, I believe, to be exact, million. Okay, you made the decision for the layoffs on February 6th, which is about roughly 35% through the fiscal year. So 35% of 818 is about $286 million. So you were either, this program, and I don't want to say you, this program was either burning hot at a rate of 3x, and you were therefore looking at an Anti-Deficiency Act breach, or the remaining money, the delta between 818, which is what you were last appropriated, and 286, which would have been your sort of SPI for a 35% profile through the FY23, was reprogrammed to another program. So this argument that you made these decisions based on an Anti-Deficiency Act actually is technically and legally not true unless you were burning at a 3x rate, or you did reprogram money to another program from MSR to something else that we weren't notified for. And I would actually submit that the appearance of what has been done here is not an Anti-Deficiency Act violation or an attempt to prevent an Anti-Deficiency Act violation, but it looks more like an Impound Act violation to me, which is where you don't execute the money that has been allocated to you with a specific purpose through congressional appropriations process. So I don't want a deference to you. I don't want you to answer that question here right now, but I would like a deeper dive into why you are asserting and your staff is asserting that the rationale for these layoffs was an anti-deficiency act, because it frankly, technically, legally, numerically, programmatically, cannot hold water unless you were burning at 3x, which I don't think you were. I understand you're in the midst of an IRB. There was confusion about the technical solutions moving forward. I understand there was confusion about the timelines and schedules that would be derived from those technical solutions. And I also understand Congress was doing you a disservice with a CR. But to baseline against a $300 million number that came out of the Senate markups is not what you anchor to when you start talking about Anti-Deficiency Act conversations. Okay, you anchor to your previously appropriated number, which was 818. So happy to let you comment on that right now if you want to. If you would prefer to answer for the record later with the actual numbers and your SPI and your actual burn rates and show us where money was being reallocated before February 6th to substantiate the layoffs, you can also do that, but I'll defer to you. I want to make sure a lot of these jobs are already lost. A lot of these people are already gone. So I don't know how we do MSR correctly without that workforce. We're already challenged, and there's already, you know, an unprecedented level of competition right now between primes to go hire these people, and they're getting scooped up. But I'll defer to you, Dr. Fox, if you want to respond.
I'm happy to take it for the record so we can get you all. I mean, you are asking for some very deep numbers that, of course, I don't have at the tip of my tongue. So we're happy to take it for the record. Obviously, again, we are, we do not direct JPL on their workforce. We did provide them financial guidance that was based on what we thought was going to be available. And having been given the information, or with the Fiscal Responsibility Act coming out at the 20, no higher than the 2023, and a cut below that, I will just note that the cut to Planetary is nearly $500 million against the 23 enacted. And it is $666 million against the president's budget request for 24. So it is a very big cut to Planetary.
Yes, but from an Anti-Deficiency Act and amount of time, that is not what you should have been anchoring to. We were allowed and we were able to continue to fight for the higher dollar levels, and so we can continue this conversation. But I'm scared. I'm scared, worried about the workforce, and it's not my district. It's Southern California, and we'll be looking for responses to the letters from the delegates from the area. Thank you. I yield back.
Thank you, Mr. Garcia. Appreciate it. Well, this concludes our hearing today, but I want to thank each one of you witnesses for being here and your valuable testimony for us to be able to have proper oversight and know what's going on with our programs. The record will remain open for 10 days for additional comments and also for written questions from members. This hearing is now adjourned.